In the next unit, we're going to be using chemical quantities, and so there are some mathematical operations or mathematical tools that we need to review in order to make you more likely to be successful in the next section. So we're going to do that in today's lesson. I believe all of you are familiar with scientific notation, but I just want to go over it one more time to make sure we're all on the same page. So scientific notation is a way for us to represent numbers that are either really big or really small without having to use quite so many zeros. So the first example I have here is the width of a human hair. If we wanted to express this in meters, that's a very, very, very small number. It has 1, 2, 3, 4, 5 zeros in it between the decimal and the 8. So that's a little bit tedious to write it that way. So let's go ahead and write that in scientific notation. So we have 0.000008. Right, and so in scientific notation, we want to move the decimal until it's right behind the first non-zero digit. So that's 1, 2, 3, 4, 5, 6 places. So in scientific notation, this is going to be 8 times 10 to the negative 6. So if we have a really small number, that exponent is going to be negative, as it is in this case. If we have a really big number, the exponent is going to be positive. I tend to not encourage students to remember the left or the right just because they seem to get those confused. Okay, so if we look at the number of hairs on a human scalp, that's 100,000. Okay, so our decimal point is right there, even though we don't usually write it. And so we want to move it 1, 2, 3, 4, 5 places. So that's right behind the 1. So that's going to be 1 times 10 to the 5th. Okay, and again, this is a big number, so our exponent's going to be positive. One other way to think about this is it tells you how many factors of 10 or how many multiples of 10 are in a number. So 10 times 10 times 10 times 10 times 10 times 10 is 1 million. So that is 1, 2, 3, 4, 5, 6 tens. So 1 million is equal to 1 times 10 to the 6th, and we could have also figured that out by moving the decimal over and counting like we did in the previous example. Okay, so then the last thing we need to do is go over how to put this into your calculator. Now there's no way that I can know exactly how to do it for all of your calculators, but my goal here is to give you a clue as to how it might get put into your calculator and have you make a note here so that I don't have to answer 15 questions about how to put this number into your calculator. So in my calculator, to do this number, 2.4 times 10 to the 13th, I would put in 2.4, and then on my calculator there's a little EE button. Okay, that represents, this represents the whole times 10 to the whatever. Okay, and then after the EE I would put in 13. That means 2.4 times 10 to the 13th in my calculator. Okay, some of your calculators will have a 10 to the X button. You can use that, but I would just like you to remember that if you do that, then when you do 2.4 times 10x, and then you would do 13 for the x, that all needs to go in parentheses, or your order of operations will sometimes get messed up when you do a problem. Okay, so spend a little bit of time with your calculator, find either the EE button, sometimes you have to hit the second button and then hit the E button. In my calculator, it's I have to hit the yellow second button, and then EE is above another key in yellow. So figure out how to do that, and then write down how your calculator outputs that particular number. So my calculator for 2.4 EE13, what I put that in, the output I get is 2.4 and an E with 13, just one E. Okay, so I need to know that when that's what the answer my calculator gives me, that means that for my actual answer on my problem, I would write 2.4 times 10 to the 13th. All right, so go ahead and take a minute and figure out both how to put it in your calculator and what the output looks like for your calculator. And make a note if you have any questions, and I can try to help you tomorrow. The next thing we're going to talk about are conversion factors, and I'm sure that you guys have done conversions in the past. A conversion factor is when you take two quantities that are equal and you write them as a fraction so that you can use that fraction to convert from one unit to another. Okay, so for example, here we have 1 kilometer equals 1,000 meters. That's the same as, or as a conversion factor, that is 1 kilometer over 1,000 meters, or 1,000 meters over 1 kilometer. Okay? So for these, we're just going to write the conversion factors. So for the first one, that can be written as 60 minutes over 1 hour, or 1 hour over 60 minutes. The next one would be 1 meter over 100 centimeters, or 100 centimeters over 1 meter. And then the last one gets into what we would do if we have a slightly different unit than what we're given the conversion for. So we know that 1 inch is equal to 2.54 centimeters. So 1 inch squared would be how much? So if we take a square, and we say it's 1 inch on one side by 1 inch on the other side, that's the same as 2.54 centimeters and 2.54 centimeters. So 1 inch squared is actually 2.54 squared centimeters squared. So 2.54 times 2.54 would give us how many centimeters squared are in 1 inch squared. And we would do the same thing for 1 inch cubed. 1 inch times 1 inch times 1 inch is equal to 2.54 times 2.54 times 2.54. So that gives us how many centimeters cubed in 1 inch. So now if we were to write those as conversion factors, a simple way to do it would be 1 inch over 2.54 centimeters and do the entire quantity squared, or the entire quantity cubed in the case down here. And of course we could flip the numerator and the denominator just like we did above. So that's one thing I want you to remember, is if we're doing a unit squared, you have to square both the unit and the conversion factor for that unit. Sometimes conversion factors aren't given to us as a simple 1 inch equals 2.54 centimeters. Sometimes we have to read the problem more closely and figure out what the conversion factor is going to be. So for example, if we have a motorcycle that's traveling at a speed of 85 miles per hour, that means that in 1 hour that motorcycle travels 85 miles. So 1 hour and 85 miles are equivalent quantities. So we could write our conversion factor as 1 hour over 85 miles, or as 85 miles over 1 hour. Similarly, if we have a vitamin tablet and it contains 500 milligrams of vitamin C, you might not initially see an equivalence there, but the problem tells you that 1 tablet is equal to 500 milligrams. So we could write our conversion factor as 1 tablet over 500 milligrams, or as 500 milligrams over 1 tablet. Now the last thing we're going to do is combine the conversion factors we've been doing with a technique called dimensional analysis. And this may seem awkward at first, but I promise you that practicing it will be worth it in the long run, because later on we're going to do problems where we might do 4 or 5 conversions in one problem, and you can just set them up all in a row with dimensional analysis, whereas I find that most students get confused if they try to do the way they've always done conversions. So bear with me. It may seem awkward at first, but I promise it will be worth it. So we have some steps here that we can use to work our way through these problems. So first you want to identify the given unit and the needed unit. So what we are given is feet, and what we need is inches. Okay? And the next thing we want to do is write a plan that gets us from the given unit to the needed unit. So we know that we can get from feet to inches using the conversion 1 foot is equal to 12 inches, okay? And then we want to choose the correct conversion factor to get the units to cancel, okay, and to provide us with what we need. And so what we need in this case is inches, and so what we need always goes on the top, okay? So put on the top the unit that you're trying to get, always. Okay, so once you've established that, so if we put inches on the top, then our conversion factor is 12 inches over 1 foot. And then the last thing we do is set up a calculation. So you always write what you're given out front, and then your conversion factor after that. And you'll know if you chose the right conversion factor because the units you're given should cancel out. So we have one in the numerator here and one in the denominator here. And so our feet cancel out, and the only units we're left with are inches. So we do 1.5 feet times 12 inches divided by 1 foot is equal to 18 inches. Okay? Now, if we have a problem like the one here where we want to go from 1.5 feet to centimeters, assuming we don't already know how many inches there are from our problem up here, for most people we would need to do a two-step conversion. You could probably Google what the direct conversion from feet to centimeters is, but we'll just use the ones that we already know. So you can get from feet to inches using 12 inches in 1 foot, and then you can get from inches to centimeters using 2.54 centimeters is equal to 1 inch. Okay, and that will get us all the way from feet to centimeters, which is where we're trying to go. So again, you start off with what you know written up front, 1.5 feet. And then your first conversion factor, what you're converting from is going to go on the bottom, so it cancels. So we want 12 inches over 1 foot, and the inches is where we're going. Okay, and then in the next conversion step, we want to go from inches to centimeters. So in this case, inches will be on the bottom and centimeters on the top. So we have 2.54 centimeters over 1 inch. And again, you have an inch in the top and an inch in the bottom, so the units cancel each other out. The numbers don't go anywhere, just the units. Okay, so we have 1.5 times 12 times 2.54 divided by 1 divided by 1, and that gives us 46 centimeters. All right, we're going to practice these a little bit in class. If you're not familiar yet with what you're doing, you'll have a chance to try again and get some help. And then we're going to introduce chemical concepts to these techniques and use them to calculate chemical quantities.